Hello students, welcome back. I am Chetan Rajoria from ABES Engineering College, Ghaziabad. I am covering up unit number 1 of the subject Fundamentals of Mechanical Engineering. The subject code is BME 101 or BME 201 through the video lecture series. So it is basically the 10th lecture of the series, and in this lecture I am going to take up the new topic, that is different types of beams, different type of supports, and different type of loads which can act on a beam. So let's start. First of all, you must know what is basically a beam. A beam is a structural bar-shaped member, a cylindrical bar-shaped member having one of its dimensions much greater than the remaining two. Or you can say the cross-section dimensions of the beam is much less than the dimensions of its length. This structural cylindrical bar-shaped member is specially designed to withstand the transverse loads. Transverse loads are those loads which act perpendicular to the length of a beam. It's not necessary that every beam is exactly cylindrical. The main purpose or the main design factor of the beam is that one dimension, which is called length, should be much greater than the other two dimensions, that is the cross-section dimensions. So generally, a beam is used together with different types of supports. So there are different types of supports which act on a beam. Without supports, any beam is useless. Only a beam can be used when it is supported at least at the one end or at the both of the ends, or if necessary, we can apply more than two supports also on a beam if the length is much greater. So there are different types of supports which can act on a beam. The first one is roller support. Second one is knife edge support. It is also called simple support. Third one is hinge support. And fourth one is the fixed support. These are the four main types of supports which are generally used with different types of beams. The first one is the roller support. So in case of roller support, the diagram is shown like this. Suppose this is the beam which is kept horizontally, and we can apply a roller support like this. Or it is also shown sometimes like this. Suppose this is the left end of a beam. So it is shown like this also. In case of roller support, the beam is free to slide in the horizontal direction. If it is kept in the horizontal position, so the beam can slide with the help of these rollers along its length to the left hand side or right hand side. So this type of sliding is allowed. So this type of support is not going to provide any reaction in the direction of its length. But through this support, the beam can be kept against its vertical movement. So it's going to stop the vertical movement of the beam. So there will be a vertical reaction because of this type of support. Let us suppose this reaction is R. So next one is the knife edge support. The knife edge support is shown like this. A beam is just kept on a knife edge, or you can say sharp edge. Sometimes it is shown like this, or it is also shown like this. It's simply resting over a fixed, or you can say a constant position of the support, and under the action of this type of support, the reaction will act perpendicular to the direction, like this. So again, in this case, in this type of support, the beam can slide along its length, but it's going to provide a reaction perpendicular to the direction of this beam. Next one is the hinge support. Hinge support is shown like this. A dot is developed on the apex of a small triangle. Sometimes it is shown like this, or it is also shown like this. In case of hinge support, the beam can only rotate about its center, either in clockwise or in anti-clockwise direction. The rotation may be clockwise or anti-clockwise, but in any case, the beam cannot displace from its position. It cannot move in the horizontal position. It cannot move in the vertical position. So the reaction will be in both the directions, the vertical as well as in horizontal direction. So there will be one horizontal direction, Rx, and there will be a vertical reaction, Ry. The direction of Rx and Ry, it may be left hand side or right hand side, and the Ry may be upward or downward, which depends upon the external force and its direction. Next one is the fixed support. Fixed support is shown like this. This is called fixed support. In case of fixed support, what happens? There is no movement possible in the beam. The beam cannot move in the horizontal direction. It cannot move. It cannot move in the vertical direction, and it cannot even rotate in the clockwise or anti-clockwise direction. So all three possible movements in the plane are stopped by this type of force, or by this type of support. So there will be three reactions. In case of fixed support, we can observe Rx, reaction along x-axis, reaction along y-axis, and there will be a reaction moment which may be clockwise or anti-clockwise. For example, I'm taking the direction as anti-clockwise. It can be positive, or it can be clockwise also. So all three types of reactions will be there. Two force reactions are there, Rx and Ry, and there will be a reactive moment which stops the rotation of the beam under the action of external forces. So these are the different types of supports which are generally utilized with different types of beams. Next, there are different types of loads which are generally used with the beams. All these loads will be considered as transverse loads. So first one is point load. Second one is UDL. Third one is UVL. And fourth one is the point moment. It is also called concentrated moment. So what are these type of loads? Point moment is shown like this. Suppose this is the beam. It is supported, and the force is acting like this. The force which act on only one cross section of a beam, any one cross section only, that type of load is called a point load. It is given in terms of Newton directly. X Newton, Y Newton, and so on. Anything, any value. Next one is UDL. UDL is the full form of this load is uniformly distributed load, UDL. So this type of force acts along a particular length on a beam. It is shown like this. Suppose the beam is supported at both the ends. So UDL is given in terms of Newton per meter, which is called load intensity of the beam. It is basically a load which acts on a particular length of a beam, on 2 meter or 3 meter or any value on a length. So it is given in terms of load intensity, which is measured in terms of Newton per meter. The intensity of the load is constant in case of UDL, remember. Now in case of UVL, it is shown like a triangle on a particular length of a beam. The intensity of the load varies from a maximum value to a minimum value. Suppose the maximum intensity is F1 Newton per meter and the minimum intensity is F2, or which is clearly zero in this case, 0 Newton per meter. So the intensity in Newton per meter varies from a maximum value to a minimum value. Therefore, the shape of the force can be considered like a triangular shape. So this type of load is called a UVL. It's not necessary that the minimum intensity is always zero. UVL is also can be considered like this. When a load intensity varies from a maximum value to a non-zero minimum value. This type of load is also considered like a UVL. Next one, the last one is the point moment. In case of point moment, what happens? Two equal and opposite forces act parallelly at a particular distance, which actually cancel out each other. The effect of forces cancelling out each other, but because of this gap, it creates a pure rotational effect. So it is shown on the beam like this. It may be clockwise or it may be anti-clockwise. And please remember, it is not a force. Okay. Previous three were considered like different type of forces, but this one is not a force. It is basically a moment which creates either in clockwise rotation or anti-clockwise rotation. So since it is a moment, it is measured in terms of Newton meter. So point moment, point load, UDL, UVL, and point moment. While calculating the support reactions of beams, it is necessary to locate the line of action of different forces. So in case of point load, the distance of the force is directly taken from the position of the force because it's only acting on a single point on the beam. In case of UDL, the position from which the moment is taken is generally taken from the center of the beam of this load, midpoint. In case of UDL, when we take the moment, we will take the distance from the midpoint of UDL. In case of UVL, we will take the distance from a point which divides this whole length of UVL and the ratio of 1:2. One ratio two. If the length of the UVL is suppose x, so the center of gravity of this force will divide the overall length of this force in the ratio of 1:2, where 1 will be the distance from this 90-degree corner and 2 will be the distance from this 0 corner where the force intensity is 0. In this way, the whole length of this UVL is divided into 1:2 parts. So these are the different type of loads. Now, on the basis of these different type of supports and different type of, especially different type of supports, we define different types of beams. First one is simply supported beam. Second one is cantilever beam. Third one is overhanging beam. Fourth one is continuous beam. And simply supported beam, cantilever beam, overhanging beam, which are basically of two types, one side overhanging or two side overhanging. One side overhanging and both side overhanging beam. Continuous beam, and last one is both side fixed beam. Apart from these five, there is one more which is called propped cantilever. In case of simply supported beam, one of the end of the beam is kept on a roller support and the other one is kept on a hinge support. Or you can say one of the end is kept on a knife edge support and other one is kept on a hinge support. So clearly there will be one reaction from the roller support and two reactions, one or two reactions on the hinge support. One of these two reactions may be zero, which depends upon the external force. In case of cantilever beam, one of the end is kept fixed and the other end is kept free under the action of different types of forces. So this type of beam is called a cantilever beam when one of the end is fixed and the other end is kept free. In case of overhanging beam, the forces may act beyond the positions of the supports. Suppose one of the end is roller and one other end is hinged. So there may be some forces which are acting beyond the positions of the beam like this. This type of beam is called both side overhanging. And similarly, there may be a case and only one side overhanging part is there. Different types of forces are acting on it. So this type of beam is called a one side overhanging beam. Next one is the continuous beam. In case of continuous beam, what happens? There may be more than two supports on the beam. When the length is much greater than the desired length, in such case, it may be possible that we can apply more than two supports on the beam. Last one is the both side fixed. In case of both side fixed, both the ends of the beams are kept fixed. So accordingly, there will be different reactions. Next one is the propped cantilever. In case of propped cantilever, one of the end is kept fixed and the other end is kept under roller support. So this is called a propped cantilever beam. So in case of continuous beams, there may be a number of unknown variables. It may be more than three. In case of both side fixed beam, the number of unknown variables may be six because two forces and one reaction on each support. In case of propped cantilever, there will be once again at least four unknown variables, two forces and one moment on the fixed support side and the one reaction on the roller support side. So there will be four reactions or four unknown variables. So if in a beam there are only three or less than three number of unknown variables, such kind of beams are called statically determinate beams. And if the unknown variables, the total count of unknown variables or total number of unknown reactions are more than three, in such case, we cannot find all the unknown variables just with the help of some equilibrium conditions. So solving such type of problems is not conventional, not that easy. Such kind of beams are called statically indeterminate beams. So out of these different types of beams, simply supported beam, cantilever beam, and some special or simplified cases of overhanging beam are considered as statically determinate beams because the total number of unknown variables will be either three or less than three. And mathematically, we will have 3 equations to solve. So such solving these type of beams is possible. Remaining three, like continuous beam, both side fixed beam, or propped cantilever, these three are considered as statically indeterminate beams because the number of equations will be three, but the number of unknown variables will be more than three, four, five, or six will be there. So solving will not be possible using those equations only. So these three are called statically indeterminate beams. So in this lecture, we discussed different types of supports like roller support, knife edge support, hinge support, and fake support. Then we discussed different type of loads, point load, UDL, UVL, and point moment. And we also discussed the location of the line of action of these forces, uh, especially in case of UDL and UVL. And last one, we discussed different types of beams, in which these beams are broadly classified into two categories: statically determinate and statically indeterminate beams. So that's all for this lecture. Thank you so much. In the next lecture, we will solve uh, one or two numerical problems based on the calculation of support reactions of beams. So that's all for this lecture. Thank you so much for joining.